Hello everyone, welcome to Module 5, Session 1, Big Data and Available Technologies. Our speaker today is Jo-fai. Please remember to drop any questions in the Q&A box. With that said, I will hand it over to our speaker.
Thank you, Franklin. So hi everyone, good morning, good afternoon, and good evening, wherever you are. Thank you for joining these sections. So my name is Jo-fai Chow, but you can call me Joe, it's easier to remember. And I'm your instructor for Module 5, AI and Big Data. So this module is the fifth module of the AI Foundations. So I hope you enjoy the module so far. And this one is about big data. I'm sure you may have heard the term big data a lot of times in the recent years. But what exactly is big data? So I'm going to explain it. So I hope that these sessions will help you better understand big data and some of the technologies that we can use to leverage big data. So here we are. This is module 5. If you have missed any of the module before, from 1 to 4, you can still go to training.h2o.ai. You can just find the video we played and the slides from previous sessions. Today, this is mainly about big data and the technologies for big data. And next, in 2 days' time, on Thursday, I will have the second sessions, which I will focus more on the machine learning or predictive analytics with big data. So this session is mainly about what is big data and how we can use different technologies to leverage big data. And also remember, over the weekend, there will be a study group on Saturday, and then there's Ask Me Anything forum on Sunday. And then next week, you will be with Ben, so he will talk about responsible AI. So we want to talk about big data, but before we talk about big data, let me give you some of my own data. So this is me in numbers. So I'm the first H2O maker in the UK. Over the last 4.5 years, I've been traveling around and try to promote H2O, and then I gave H2O talks and workshops more than I could remember. So I would say 100 times or more. And I've been doing that in over 40 cities around the world. So in Europe, in US, and Asia. So I also manage some H2O meetup group. So especially those in Europe, the one in London is my biggest group with 11,000 members. So these are my numbers. What I also want to mention is that I wasn't studying anything about data science or computer science at all. So I was more of the boring traditional civil engineer. I learned about data science. I learned about open source tools like R, Python, all by myself back in 2013. And I discovered H2O around 2014. And somehow, with some luck, I joined H2O in 2016. Because I was the first person on the ground for H2O in UK. So I've been through different roles. I've been a data scientist, a sales engineer. I manage the community, look after the customers. And now my current role is a senior data science evangelist. So I talk a lot about H2O with different use cases. But most of you, or some of you may have seen my photos before. And this is my specialty, my skill. It's called 360 selfie. And I did a lot of selfie before the lockdown. So whenever I went to visit a new place with new meetup groups, I try to take a photo with everyone. But this is all history now after the lockdown. So hopefully one day we can travel safely again and I can do more 360 selfie. Okay, so back to the main topic. What am I going to talk about today? So first of all, I need to go through the term big data. So what is big data? And then I want to discuss a few ways to describe or to characterize big data. How can we actually talk about big data? And more importantly, I want to show you the value of big data. And then in part 3, I'll talk about some of the technologies that we can use to leverage and to extract value from big data. So there are lots of technologies available in the market, so I won't be able to talk about everything, but I will pick a few common technologies and discuss them. And finally, I will summarize the sessions and tell you a little bit about the next sessions. So let me pause here for a few seconds for the video. So part 1, what is big data? So what exactly is big data? Nowadays, big data is everywhere in our daily life. So whenever you post your photos or videos on Instagram, you tweet it on Twitter, you do any kind of online shopping, you do a passport scan at the airport, do a Google search, you do send a voice message to your loved ones, you do a barcode scan at the supermarket, any CCTV footage from the security, everything is big data. So we are generating a lot of big data every single day. And we can mostly classify them into 3 different types of big data. So they could be structured like Excel spreadsheet or stock market values. And you can also look at the video, photos, sound as the unstructured data. And sometimes it can be a mix. It could be a both. So think about on social media, you can tweet a photo with the location of the places. So you can combine both unstructured data and structured data. When you generate big data nowadays. So it's kind of a bit of a mix of everything in today's term of big data. But before we get into more details, so we need to look back. So how did we get here? So how did we get from small data to today's big data? So let's look back in time. Okay, so I want to show you a simple timeline of big data. So all the way back to 1991. I'm sure some of you may not remember the time before internet. So, but let's try with me. Let's try to imagine the world without internet. And then there's a birth of internet back in 1991. So it wasn't available to most of people because it was still a new technology, and then it take time to for organizations to get prepared. But it was born back in 1991. And a few years later, there's another milestone because digital storage became cheaper or became more cost-effective than paper storage. And this is a time when organizations start to move the data, move their records from paper storage to digital storage. And then Google search engine was born. So it was launched back in 1997, and the Google company was founded a year after. And this is another huge milestone because now from then people can actually find the information they need really quickly from the internet. And then in 2006, we got a new technology called Hadoop, which we will discuss later. And this allows scalable data processing, which is another milestone because before we have this kind of technology, we kind of have a bottleneck with the hard drive, the hard disk. So we cannot process the data, all this huge amount of data generated from the internet effectively. But from 2006, we have the kind of new technologies to process them in a scalable manner. So we can actually increase the capacity by adding more cluster, more computer, more machines to the cluster, so we can have more processing power to process data. And just 2 years after that, we have another milestone. So we hit almost 10 zettabytes. So what is, I didn't know what zettabyte is. So it's actually about, is trillion gigabytes. And it's hard to imagine it in my head. But that's the amount of data we processed in a single year back in 2008. And not long after that, we also have another change in our lifestyle because there are more people using the mobile device, could be their phone, the tablet, to access the internet than using the desktop PC. That's another change of behavior. And this only to today's, when we look at the market value of big data and analytics, is valued at 203 billion US dollar. And that is a huge market. So let's look again at our statistics. Now, this is from last month from We Are Social, the website, which you should check it out. Our population is standing at about 7 billion, and many of us have mobile phones. So there are 5.15 billion people with mobile phone. And who are using the internet? So we have 4.57 people using the internet. And the last figure is about how active we are on social media. And it turns out more than half of the populations are active on social media. And that kind of explains one of the questions I had a few years ago. So why do we have so many cats on the internet? It's us. It's just us. Just keep posting cat videos and photos on the internet. We keep generating more and more data. Of course, not all about cats, but cats are one of the major trend in the last couple of years. And today we are also generating data, actually right now, because we are using Zoom, and every day, in the last month, there are 300 million people doing Zoom meetings every single day. And also that they are also using other platforms to do these virtual meetings. So, COVID-19 has kind of changed our lifestyle, and then we are also generating a lot of new data, as a side effect. Okay, so let's summarize part one. So we know that it's been a long way since the birth of internet. We try to turn paper storage into digital storage. We try to look at ways to have a better search engine with Google launching the search engine and helping people to find information on the internet. We have breakthrough in data processing, so we can have Hadoop and other technologies afterwards to process data in an efficient manner. And we also have more people using mobile device nowadays. And then as a result, we have a huge market for big data, valued at $203 billion today. So the next question is, how can we describe big data, and how can we extract some value from all this data? So in the second part, I want to show you a few terms that we can use to describe big data. So the characteristics of big data, and most importantly, I want to show you the value of big data. So this is one of the usual or common 5 V's of big data. So if you Google the V's of big data, you may find other versions. So it could be 4, 5, 6, 7 V's. But this is the most common 5 that I like to use. So we start from volume. Volume is the most obvious one. We got a huge amount of data generated every single day. And we also come from different kind of source. So we got a variety of data. And they also come in really, really quickly because we are using mobile phone every single day, every single second. So they come at different velocities. And sometimes you can't trust everything you see on the internet. And that's when we talk about velocities of the data. And lastly, we want to talk about the value of big data. So let me just go through them one by one. So this is a chart from Statista. So this is about the growth of big data from 2010 to 2024. So we know that is a continuous growth of big data. And I don't think this trend will change anyway. So we just keep going and growing. So we need to think about what are the technologies, what are the methods to store the data and how to access the data efficiently. So that's the first V of big data. The next 2 V's of big data is the variety and velocity. So first, let's look at variety. On the right-hand side, you can see this is only about the internet usage. So this is 1 internet minute in 2020. How many things could happen in just 1 minute? You can see a lot of people are doing online shopping. So $1.1 billion spent online just for 1 minute. And then we can also look at the other platform, TikTok, emails, Twitter, Instagram. This is only about the social media. And if you think about data from other sources like Internet of Things or the sensors on the car, your data from your health tracker, those are things that are all adding up together, and they are coming from different kind of structure. Some of them, they're just numbers, so like the stock market value, and some of them, they are just video or image, they're unstructured. So there are many different kind of data coming into the system. A lot of data going in the system every minute. So we need to think about both the velocities and variety of big data when we try to describe big data. So the next one is I have an example here. So here's how much you can trust the data that you collect from different systems. So this is one. This may not be the typical example, but it's one example. So there was this gentleman here in Berlin. He tried to trick the system. So he put a lot of mobile phones on a tray, and then he walked to a street next to Google Berlin and just stopped there. So this kind of tricked the system into thinking that, oh, there are a lot of cars getting stuck on the street, and they trick the system to think that, oh, there's a huge traffic jam next to Google. And that is kind of one way to explain. Sometimes you cannot just trust everything in data. You need to have some sense check before you move on to the next stage of analysis. So finally, I want to look at the value of big data. So there are actually so many use cases that you can think of with big data. So you can also see that this is some examples, some typical use case from our own experience, from actual experience. We work with different customers in different sectors. So start from financial service. We can look at the credit card risk scoring. That's the most common thing that you would do with financial service. And you can also look at anti-money laundering. So all these benefit from the use of big data. And because we have so that many use case here, this use case will help different organizations to gain different competitive edge or in different sector. So you may consider examples like looking at the customer churn. How can we prevent customer from churning, from leaving your organization? So we can look at the data and see whether there are trends that showing that no, there people are not happy with some of the service, and what can we do to retain them, kind of make them happy again. And there are so many things that you can do just by using data and create the models to model the behavior of different customers. And in other sectors, for example, telecom, so sometimes you want to do predictive maintenance. So for example, you want to predict whether you need to go and fix some of the hardware in the network, but you don't want to fix them on a regular basis. You want to predict whether they will have problems at some point in the future. And that's where you want to do analysis on predictive maintenance. So you can kind of predict maybe in different areas, some of them you predict that they will have a more hardware failure than the others. So you will spend your resource, you kind of think about the resource and prioritize your schedule to look at the most problematic area first. So there are so many different big data use cases. So let me dive into two particular examples and show you how actually you can gain value from using big data. So this is Vision Bank Group. This is a bank in Paraguay. So what we're trying to do with them is to use data and try to match the customer in the past, how likely they are going to buy more new bank products. So using that, we learn the patterns from the customers in the past. So using historical data, look at the patterns and use it to create a new system that recommends products to existing or new customers, so that we have a higher chance to promote the right products to the right customers. And that, as a result, they have 2x increase in capacity for their customers to buy new bank products. And that is a really significant return of investment for them. The second one is a bit different. So this is one that we try to mimic what an auditor would do when they look at different records. So we're trying to create a system that kind of mimic like a junior level of auditor, and see when they look at different kind of records. So these are mostly transactions from different companies. So the job is to look at some of the problematic numbers. So it could be fraud, could be other issue with the transactions. But in the past, when they try to look at this like manually, they couldn't do it. They couldn't look at all the records. The way that they have to do it, they have to sample the record and try to look at as many as possible. What we are trying to do, what we actually did with PwC, is that we create a system, a clever smart AI system that can mimic the auditor. So we kind of turn the transactions into a data format that we can use it, we can digest and create models. So this model will give the users percentage of fraud, maybe some percentage of indications that some of the transactions may need further attention. So this actually helps them to save months or even years of human time. Look at all the records, because in the past they have to do sampling, but now they can use this system to go through every single record in a timely manner. And with that, they can ask the expert, the human expert, to focus on the most high-risk situations, so most likely fraudulent events, and use the time more properly to focus on those, because these are the events that really counts when you want to look at, when you want to track down all the fault from the system. So these two are some examples of using big data, train a system, and use AI to help human perform better, to help the business to gain a better edge in the market. So I don't have time to discuss more use case, but you can find a lot more use case on our website. So you can see the link on here, and here you can find use case in different sector. So I hope that when this is finished and if you want to find out more, please go to our website and look at the use case, solutions and use case. Okay, so I'll talk about 5 V's of big data. And we talk about how you can describe the volume, the velocity, the variety, and value, voracity of data. And now the next question really is, we want to extract the value, but how? We want to have some technology, some tools to store and process data in a systematic manner. So the next section is about the technologies. Part 3. So this is about big data technologies. So let me just show you some of the challenges that we have with big data. So before we go to look at the technologies that we can use to solve this challenge, let's talk about challenge. So these are the 4 most common challenges that we face today. So the first one is quite obvious, is the data growth. So we are generating more and more data every single day. So we need something with efficiency to store data, so we will have a chance to analyze them afterwards. The second one is about the timing, about how fast or how you can complete your analysis, because the volume is huge. You need to prioritize your process so that you have a chance to get the result in a timely manner. Otherwise, you may have to wait for days or weeks to get the result, and that is not good enough for today's business. So we need to think about how we can generate some insight in a timely manner. And the third one, we just mentioned it here, we are not going to talk about the technology about it, is about the data security. So how can we prevent attacks from hacker, and how can we prevent leakage to other people? So this is something that we also need to consider when we build infrastructures for maybe your organizations or other organizations. And the last one, hopefully that we can kind of solve it with the online course, is the shortage of talent, shortage of skilled data professionals. So I hope that by doing these online courses, you get more and more interested in data science and all technologies around data science. So hopefully one day we'll have more and more data talent in the market to solve all these problems. I'm not going to scare you with a big landscape picture, but this is what we have last year. There are so many tools, so many technologies available. So not all of them are the same, but some of them, they're trying to solve the same problem. I hope that you can find H2O AI from this graph. So it's quite yellowish. But what I want to focus on is some frameworks for big data. So in particular, I want to talk about Hadoop and Spark. So we don't have enough time to talk about everything else, but do have Google them and find out more about different frameworks, different technologies, because I don't think that one single person on this planet who can manage or master all the tools you can see from this landscape. But you don't have to learn everything in one go. But when you get into data industry, when you get into different organizations, you will know that what kind of framework the people, the organization are using, and you start to learn from that point. So you don't have to actually force yourself to learn everything in one go. But let's talk about 2 common frameworks here, Hadoop and Spark. So I try to make it like as simple as possible. So that there are two core components for Hadoop. The first one is about storing data. So this is the first step. So how do we store different data in what we call the Hadoop distributed file system? So we call HDFS. The way that we think about it is to split the data. So from one big chunk of data into smaller chunks. So in this example, you can see that we split it from 300 megabytes to smaller chunk. And we can store them on multiple machines. So sometimes we call it data nodes, or sometimes we call it clusters. So just different machines that each one holds a bit of data together. The next thing we want to think about is how we store them in a distributed manner. Just in case one of the machine is shut down or there's any fault with the machines, because this gonna happen. None of the hardware can last forever, so we expect that there will always be some redundancy, and there will always be some problems with one or two machines in the system. So the way that we think about it is that we make copies of different versions of the same data and put them into different machines. So in that case, we have kind of an insurance policy here to make sure that it's fault tolerance. Just in case one or two machines gone down, you still have a copy of the original data somewhere else. So that's what you can think about as a Hadoop distributed file system. So the next component is about processing big data. So we call it Hadoop MapReduce. So the idea is to break down a huge task. So we call it task A here, which could be quite time consuming on one single computer. We try to split it into smaller chunks. So for example, some of the tasks like summation of the data column, they could be done in different machines together and in a parallel fashion. So say I split it into task B, C, D, and each of them, they are much smaller tasks. They can be done on different computer really quickly. Like from task A that you have to do it in hours. So you can split in task B for a few minutes on one computer, but at the same time, you can use more computer to run task C, task D, and so on. So it can all be done in a more timely fashion. So after all the results are collected, they can be combined into a single result, and that will be the final result from this Hadoop MapReduce task. So let me use a more daily life example here. For example, you want to make a sandwich with all these ingredients here. So when we try to do the map step, so we want to break it down into smaller tasks. So you can see that I break it down the baguette, tomato, lettuce, onion, and pepper. Or break it down into really, really small pieces. And then we try to group them into the right orders because we want to make sure that we are doing the right task. So we group them, so put them the right ingredient into the same group. And the result, when we do the reduce task, we make them into a proper sandwich. And that's some of the way that you can think about how we do MapReduce with Hadoop. So of course, this is more like a funny example. So if you want to find out more about Hadoop, just go to the links I have included here. And there you will see more computer science example from those links. Okay, so next I want to talk about Spark, or Apache Spark is the full name of Spark. The main difference is that Spark is using distributed in-memory data processing. So if you look at the graph here on the top right here, when we do the same thing in Hadoop, it's like when we try to do a MapReduce in Hadoop, they always write it to the disk first. So that is a step that that could be quite time consuming when you do a lot of write and read using the hard drive. But in Spark is more like a more recent technology than Hadoop. It was developed a few years after Hadoop came out to the market. So we try to do something similar but different. We try to do the MapReduce step in memory. So everything, unless the users has to write something or have to read something from the hard drive, we keep the result in the memory. And in this way, we can do it a lot faster than the original Hadoop approach. And Spark is also like an engine that you can connect to more platforms. So you can work with Hadoop. So Hadoop will be the storage platform for that. You can also use other platform that I don't discuss here, but you can find out more. See how you can connect Spark with different platform, and then you can use data on different platform and process them using Spark. So the next thing I want to talk about is data lake. So this is also a common term that you may have heard of. For example, this is a very simple diagram showing the flow of data. So on the left-hand side, you see that you have different data source, could be a customer record, could be a time series, could be anything. We put them into data lake in the first system here. So we keep the raw data set. So we don't change anything here. We keep the raw record of everything from the data source in this system here. And then we have a choice for different users. Because, for example, the data engineer or data scientist, they may want to get their hands on the raw data sets so they can do their own data wrangling or any kind of processing themselves because they have the skill to do so. But some other users, maybe business user or business intelligence users here, they may not want to do the same step. They may not want to go through the data munging or any other processing step. Just want to have something ready for them to consume. So in this case, there are people who can design different step here. This is like a core processing step. So we will turn the raw data into different formats that can fit into what we call data market. And people, other users here can look at this market and take what they want, take what they need to use. Could be for the report or their annual report of sales record, could be for anything that they just want to consume data in an easy, user-friendly way. So this is what we call a data lake. So we try to make it easier to store every data, all the data source in a raw format. And we also have more flexibilities for people to use a raw data or use some prepared data set, preprocessed data set for different purposes. And that's also like a component for governance. So we make sure that the data is getting into the right, with the right quality check, and everything is managed in this data lake. Okay, so the next thing I want to talk about is H2O3. I'm sure that if you join our learning center, you have heard about H2O3. So this is our open source machine learning platform. And when we first start with H2O3, the main goal is to create a platform that is scalable for machine learning. And this is the key idea behind H2O3. So how can we leverage other technology like Hadoop, Spark? How can we use other technologies together and build a platform that we can use it for machine learning in a scalable fashion? And that's why we have this H2O3. So we have different algorithms, so supervised and unsupervised algorithm written in Java. We make sure they are highly optimized in Java, so they are more scalable. And the other thing we want to make sure is the current, the APIs, because we know that the end users, the data scientists, or other business users, they do not want to use Java for machine learning, like most of the time, really. So we have APIs available in R, in Python, in Scala, and we also have a web interface called Flow. So you can learn more about all this from our tutorial, and then for the next foundation course, we have the ML Foundations, which will give you a lot more hands-on tutorials and workshops with more and more examples. For this one, we just try to keep it simple and try to give it as a high-level business story about different tools. So a quick thing about a quick overview of H2O3 and how we can leverage different platforms. You don't have to pay too much attention on how everything is connected. So the main thing here is that we have the actual compute engine in the middle. We can use data from Spark. You can use data from Hadoop. We can use the same kind of infrastructure, like the machines that you built the infrastructures for Spark and Hadoop. We can use the same machines for H2O. We just allocate some memory and CPU resource for H2O, and then they can use it for machine learning. And that's the idea of scalable machine learning with H2O. So we try to leverage the platform that we have on the market, try to leverage the infrastructure that people may have in their organizations or their own use. So try to distribute the machine learning tasks so that when you need to speed up your model training process, you can increase the number of machines. You can scale up the process horizontally. And that's the main idea of scalable machine learning with H2O3. So that's a lot from our side. So how do our users and customers actually use H2O at scale? So I have an example here. If you want to find out more, please go to this slide share here. You can see it from our customer from booking.com. So what they found out is that they have been looking at different tools for their business, for their machine learning requirements. So if you look at the chart here on the right hand side, this is like on the x-axis is the size of data from 1 to 10 million rows to 100 million rows and more. So this is some of the funding they have. When you have kind of small data sets, so for example, less than 10 million samples, you can use open source tools like R, like Python, scikit-learn, H2O on local machines. You can use that. And you don't have to use any cluster. You don't have to use any Hadoop or Spark technology to scale it up. But the picture change when you have more and more data. Like for Booking.com, they have billions of data. So they test different framework. They test TensorFlow, they test Robit, and then they hit a point where you can't use any kind of this tool anymore. You have to go for Spark, and that's when they find out that H2O with Spark, so we call it sparkling water. That is the framework they're going for when they need to train models on lots of data. It's a lot more than a single machine can handle, and they have to use multiple, like hundreds of machines together to build a cluster and use that to train the model. Okay, so we talk about different technologies to store, to process, and to extract value from big data. So, but what are the real world example? What are real world predictive analytic example of big data? So I will talk about more of about that in the next sessions. But to give you a quick teaser, this is one of my project back in 2018. So it's some of you may not know about baseball so much. I didn't know much about baseball because it's more a sport for Americans. And but I did a real project with Ari Kaplan. He's one of the real Moneyball persons in today's market. So he had a team. He has some data. He has some data from different players, different baseball players at that time. So what we try to do together is to try to predict the actual performance in the next couple of years. And this is the way to find some of the undervalued players from a lot of players. So find out which one would be the best with the budget. So we did it, and then we actually found a player that his team won, and that became a real contract for multi-years, so more than 20 million. So this, I'll talk about more in details in the next sessions. Okay, so what's next? So the next session is in 2 days' time. Will be one about all the use case or the real world use case. So call it predictive analytics with big data. So around the same time on Thursday. So I hope that you can join us again. And then there will be a study group on Saturday, and then Ask Me Anything on Sunday. And then the module next week is about responsible AI. So I still have to finish the quizzes, so they should be available patients after these live sessions. There will be one for the module, and you have to complete that. So if you want to earn the badges, you need to complete the quizzes. So I'll make them available as soon as possible. And some resource that you might have seen it from previous modules. So these are the links to our glossary, to the different webinars. So we will try to put more and more resources on the discussion chat box. So whenever you have questions, you can just ask us here, and then you can also use the discussions in the training center, and you can we can post continue to post more links to more resources. But that's all I have for you today. And I'm ready for some questions. So I can see that there's a question about timeline. So let me go back. Okay. So what is the question about the timeline? Is there anything that you want me to explain further? Oh, don't worry about the link, because after this, the slide will be available. So you will be able to click on the links from the slide. No problem. You're welcome. Okay, let me see the questions here. Okay, let me answer different questions here. So the first one is like, does HOV use Hadoop compute cluster for processing? So we now for Hadoop, we mainly use it for storage. So when you use HO on top of Hadoop, then we can use the same clusters for all the heavy lifting. So for machine learning training, and then anything that you need to do with HO, we can use the same clusters. And second question is about the 100 million rows of data benchmark. So that, of course, is now the company secret. I don't work for Booking.com, so I don't know exactly about the setup. But you can look at the business as a whole. Now, Booking.com, they have their own cloud company, kind of like a support department that somehow became a company on its own. So they have their own network that has to be taken care of by some professionals. So I'm sure that they think about the latency of the before they set up the cluster. So they have to make sure that they have a low latency between different machines in the cluster to actually make it work. Otherwise, it will take too long to train the model because of the latency. So Elasticsearch might work. So it really depends on how you want to create a pipeline. So if you can create a pipeline properly, so getting the result, anything from Elasticsearch into the HO pipeline, then it should work. So it's just about how you can configure the whole pipeline together. It's not working out of the box, so you do have to configure your pipeline properly. So to get the input from Elasticsearch and then into HO as a platform. Okay, Veracity again, of course, this is about how trustworthy is your data. For example, there are news coming up on coronavirus every single day. Now they are coming into the system as social media posts. How much can you trust them? How much can you use them to make your own decisions? That is something one of the issues about big data, because it's not selective when we collect the data. All people have their own opinion. They can post whatever they like on the internet, and the system just store them. They're not selective. They just store the result. But it's up to us when we try to analyze the result. It's up to us to do our own sense check before we make use of any of the data, and that is the veracity about big data. Okay, so about the model with the CPU from data. So that's the data put together from into this big data trip. For example, you use something like SQL to get more data, and if you have not, use something like Apache Spark. There seems to be a lot of data. Again, this is about the configuration of pipeline. Now, different organizations, they have different requirements. Some of them, they can use just the traditional relational database. Some of them, they use Hadoop. Some of they use Spark. It really depends on I think the upstream configurations. And once they have the first table result, for example, for machine learning, for supervised learning, you have to have features and target for HO3. So if you can formulate that, you can configure the pipeline into using those tables, then you can use HO in the next page of the pipeline. Okay, so the next one is about the scoring environment. So we have our most recent scoring environment is called Mojo. It's something that we optimize for scoring. So you can embed that with Java. So we also have other environments, so C++ environment to use in Mojo. So we try to make it as easy as possible to fit in different scoring environment. If you want to stick with the native R or Python, you can also do that. So you can just train the model using R or Python, keeping that actual cluster alive. So it's in Java, JVM, Java virtual machines, keep it alive, and you can use the same environment that you train, like in RStudio or Jupyter Notebook, and you can reuse the model in that environment. But mostly for real usage, we'll use module in Java or C++. Okay, the last question is about multiple target column in a single column value. So it depends on how you want to frame the machine learning problems. So do you want to do a simple binary classification? And if so, you can change it to 0 or 1, or 1 to nothing, or 1 to all configurations. If not, if you want to do it all in one go, so for example, in a single column, you want to have 100 products as a classification, you can also do that. It may not have your desired results because we come up with probabilities of 100 classes. It may not be the most practical predictions for your organizations, but you can test different configurations. In practice, I would say sometimes people can simplify the products, simplify into groups, simplify into 1 or 2 products first, and then try to do the classification for their business problem. But if you really want to do 100 products, there's nothing to stop you from doing that as well. So, but you may not have the desired results. Right. So I have answered all the questions. If there's anything that you can think of, you can still let me know in the next 5 to 10 minutes. I'll be here. Thank you. Yeah. So I think I've answered many of your questions before, but only in the text format. So thank you for being with us so many times. So I hope you will join us again for the next sessions and the following ones as well. Okay, so if there's no other questions, I may wrap it here. So again, we have the second sessions, which I will talk about or real life use case of big data with machine learning on this Thursday about same time. And then we have the study group and ask me anything over the weekend. So please try to join us again for next sessions and then next week and so on. So after the whole AI Foundation module, we'll have we'll move on to the next one, which is the ML Foundations. In that case, I will show you a lot more like hands-on example of machine learning. All right, thank you, everyone. Have a good day. Oh, there's also there's a new question here about the production scoring. Yeah, that's related to model scoring. So once you train the model, be it your supervised learning model or unsupervised learning model, you want to reuse the model, and that's how we call it scoring. So you can apply the model to new data set, and that will give you some predictions. Could be a sales record, could be classification of different classes. So that is how we call model scoring. Okay, let's call it a day. I'll see you again in today's time. Thank you.